All right, let's talk about something you've probably never seen, but that you rely on every single day. It's called hydrostatic testing, and it is the ultimate pressure check. The critical safety process that keeps our entire industrial world from, well, blowing up. So yeah, it's pretty important. Let's get into it.
I mean, just think about it for a second. All around us, under our feet, there's this huge, invisible network of pipelines, tanks, and vessels. They're all holding back incredible amounts of pressure to move our fuel, power our factories, and store our water. So what's the one thing that guarantees all of that pressure stays where it's supposed to?
And that right there, that is the fundamental challenge. How do you prove beyond a shadow of a doubt that something is strong enough to handle extreme pressure before you put it into service when a failure just isn't an option?
This hidden network is absolutely everywhere. We're talking massive pipelines for oil and gas, complex pressure vessels in factories, giant storage tanks, boilers, you name it. And every single one of them contains an enormous amount of stored energy. So a failure, that isn't just a little leak, it could be catastrophic. That's why having a rock-solid, reliable safety test isn't just a good idea, it's non-negotiable.
So, how do you safely test something that's designed to hold that much force? Well, the answer is so elegant, so simple, it's been the gold standard for decades. You use water.
The official name for this is hydrostatic testing, or just hydro testing. Basically, it's a test where you take a component, you fill it completely with water, and then you pressurize it way beyond what it would ever see in its normal life. It is the single best way to prove that a system is structurally sound, totally leak-free, and absolutely safe to use.
Now this is where it gets really fascinating. Why water? I mean, you could use air, right? That's called a pneumatic test. But here's the problem. Air is super compressible. It's like squeezing a spring. It stores a massive amount of energy. So if a system fails with air in it, you get a violent, dangerous explosion. Water, on the other hand, is practically incompressible. It stores very little energy. So if a hydro test fails, you usually just get a leak or a split, no explosion. The difference in safety is just night and day.
And you gotta understand, this isn't just some rough and ready process. Hydro testing is a precise science, and it is governed by some very strict, internationally recognized rules.
It all really centers on a critical safety margin. Generally, a system is tested to 1.3 times its maximum allowable working pressure, or MAWP. And that's not some random number. It's an engineering principle that builds in a huge buffer for things like metal fatigue, future corrosion, or any unexpected pressure spikes. So a pipeline built to handle 1,000 psi, it's going to get pushed to at least 1,300 psi during the test to prove it's got what it takes.
And this isn't just a local guideline. This whole process is meticulously standardized across the entire globe. That means a pressure vessel that gets certified in Germany has to meet the exact same safety standards as a pipeline tested in Texas. It creates this universal language of safety and reliability.
And this is where that serious engineering rigor comes into play. You have these codes from huge organizations like ASME, the American Society of Mechanical Engineers, and the American Petroleum Institute, or API. They have written the literal rulebooks that spell out the exact test pressures, how long to hold them, and what counts as a pass for everything you can imagine.
Okay, so we've got the what and the why down. Now for the really cool part, the how. We're going to walk through a real-world 6-step field guide that industry pros, like the expert teams at Bowsher Energy, follow to get a hydro test done safely and done right. First up, you can't just show up with a wrench and a bucket. This is highly specialized work. We're talking about incredibly powerful high-pressure pumps, super precise digital gauges, and data loggers to track everything, and all the heavy-duty hoses, manifolds, and safety valves needed to control the whole operation. The whole thing kicks off with intense planning, engineering reviews, risk assessments, the whole 9 yards. Step 2 is prep, where the system is isolated and slowly filled with water. And the most critical part here is venting out every last bubble of air. Any trapped air is a pocket of stored energy, and that's a big safety no-no. Then for step 3, you start adding pressure, but you do it slowly, in stages, so you can check for any issues along the way. So after the system holds pressure for the required time, you just reverse the process, right? Well, just as carefully. Step 4 is releasing that pressure slowly and under control. Step 5 is getting every single drop of water out to prevent any future corrosion. And finally, step 6 is putting everything back together and officially certifying that system as ready to go to work.
But after all that, how do the technicians actually know if the test was a success?
Well, the final verdict comes down to a really clear, straightforward set of pass-fail criteria.
To get the green light, 4 things absolutely have to happen. 1. 0 visible leaks. No drips, no drops, nothing. 2. The pressure has to hold steady. It can't drop. 3. No physical signs of stress on the equipment, like bulging or bending. And 4. The data logger has to show a nice, flat, boring line on the pressure chart. And trust me, in this business, boring is beautiful. If you get 4 check marks, it's officially safe.
So let's zoom back out. We've gone through all the technical details, all the steps, but it all serves one single crucial purpose.
And that purpose is safety. Even though hydro testing is inherently safe, you're still dealing with high pressure. So the pros take 0 chances. They set up barricaded exclusion zones, they wear mandatory protective gear, they have multiple safety relief valves, and like we said, they are obsessed with getting all the air out. Safety is the top priority, from start to finish.
So at the end of the day, it's pretty clear why hydro testing is the undisputed champion. It is by far the safest way to find leaks and hidden flaws. It validates that something is strong enough for the job before it ever goes into service. It guarantees compliance with all those critical safety codes, and ultimately it protects people, it protects property, and it protects the environment.
You know, hydro testing is just a perfect example of the incredible invisible engineering that's working all around us, all the time, just to keep our world safe and running smoothly. And it really makes you wonder, doesn't it? What other invisible safety systems are out there, quietly protecting you every single day? Something to think about.